Good morning to one and all. I welcome you all to the Thermodynamics course. Myself, Arun Kumar K, Assistant Professor from Aeronautical Department at MLR Institute of Technology, Hyderabad. So, in the previous lecture, we discussed about limitations of first law of thermodynamics. In today's lecture, we are going to discuss about second law of thermodynamics and its various statement given by the scientists, various scientists. Right. So, without further delay, we'll enter into the today's topic. See, these are the various statements actually we are having with respect to the second law of thermodynamics. Right. See, with respect to that particular statement, actually, I can't able to sense the second law of thermodynamics. Why? Because we are having various limitations with respect to first law of thermodynamics. So, I need to overcome that. So I am supposed to give various statement for that. Got it? So that is why we are having these are the various alternative statements with respect to the second law of thermodynamics. See here, there is no simple statement that captures all aspects of the second law. Because we are having almost majorly we discussed about three limitations. Right? So with the three limitations, I can easily overcome. I can easily enter into the second law of thermodynamics. Right? See, several alternative formulations of the second law are found in the technical literature. Right? So, in that, see, we are having various alternative statements, but in that, the prominent ones are the important or the primary ones are actually we are having the Classier statement, and we are having the Kelvin-Planck statement. Right? Once I frame these two statements, then actually I'm going to enter into a new concept is nothing but actually we are having the entropy statement. See, in the first law of thermodynamics, for the closed system, as we discussed, the change in internal energy. But whereas for the open system, actually I said that is nothing but, right, we are having the internal energy change plus flow work done because of the flow of particular working substance. So then actually we have entered into one more technical term that is nothing but enthalpy. Right? So in the first entry we have discussed in that way. Similarly, if I go through with respect to this various Classiers and Kelvin-Planck statement, right? So the Classier statement is nothing but actually we are having the cold body to the hot body transfer of energy. Right? See, this is what actually we are having. The cold body is nothing but, see, I can able to say lower temperature, TL, temperature lower, to temperature higher. Right? So this is actually we call it as a non-spontaneous process. So for the non-spontaneous process also I can able to apply the law of conservation of energy, right, with respect to the by overcoming the limitations. Here the Kelvin-Planck statement is nothing but again we are having the directional property. See, TH, that is what, hot body to cold body. So this is where the transformation takes place. Now we are having the directions, right? See, with respect to this, actually, if I overcome, what happened actually, I can able to enter into the new parameter, that is what, the entropy, and we are having that as the entropy statement. See, this leads to the third law of thermodynamics that we will see, right? So these are the primary statement actually we are having with respect to the second law of thermodynamics. So one is nothing but Classier's and another one is nothing but Kelvin-Planck statement. Right? See, this is applicable with respect to spontaneous process as well as non-spontaneous process. Simply we can able to say, always I consider with respect to the heat engine, right? Heat engine. So what is that heat engine actually we are having? The heat engine is nothing but the high temperature body. So that is having plenty of heat energy source. Right? So from that actually I can able to get the desirable mechanical work output by rejecting some heat energy to the sink, or because we are surrounding with respect to that lower body temperature. Right? So that is what actually this is what the spontaneous one. Why? Because the heat energy supplied to the system is nothing but always we consider as positive. So that is what the universal sign convention we are having. Right? So with respect to that, I can able to easily sense This is applicable with respect to the heat engine. Which one? The Kelvin-Planck statement. But in that also, we are having the particular conditions. Right? But in the first law of thermodynamics, we are not having any sufficient conditions. But here actually, I can able to mention the conditions also. Then I can able to frame the particular heat engine which is having, which is transferring the heat energy from higher temperature body to lower temperature body. So for that kind of systems, we can able to apply this Kelvin-Planck statement. Right? So that is the primary one. That is very easy to understand actually. And what is the next one actually? Class A statement. So in the actual cases, we can able to transfer the heat energy from lower body to higher body also, until if you are supplying the work input to the system. The best example is nothing but actually we are having as refrigerator, or we can say room heater, that is what heat pump. Right? So in these conditions actually we are transferring the heat flow or heat energy from lower body to higher body. So I can able to mention I specified the direction also over there. So I have overcome that, and how much also we can easily able to sense with respect to why, because I'm having lower body temperature and higher body temperature. These are the specific conditions we are having. But over in the first of thermodynamics, I didn't mention any higher body and lower body temperatures over there. Right? So with that I can able to evaluate. Why? Because so with that I can able to sense how much heat is rejected or heat losses to the surrounding. That is what sink. Right? Or lower body temperature. So if I sense that, I can able to evaluate the performance parameter over there. Got it? So in the refrigerator, right? In the refrigerator space, so inside the refrigeration, what we are having actually, the refrigerator space we are having, that actually is supposed to cool down. For example, assume that already I am having that as 20 degrees Celsius, right? But even though I need to reduce that to 10 degrees Celsius. Got it? So, but the surrounding temperature is nothing but actually the average surrounding temperature of Indian atmosphere, we can take 30 degrees Celsius as the average one. So the refrigerated space is nothing but actually I'm having 20 degrees Celsius. So we are transferring the lower body temperature to the higher body temperature. So that is also feasible, right? So that limitations also we have overcome with the sign of thermodynamics. That is what actually we are going to discuss with respect to this statement. So this is what actually the overview we are discussing right now. So the primary ones is nothing but actually we are having the Clausius as well as the Kelvin-Planck statement. So these are the prominent ones. So the other statement also there. But with respect to this, actually I can able to easily sense with respect to the spontaneous process and non-spontaneous process. Right? So for the non-spontaneous process also it is feasible actually. And for the spontaneous process also it is feasible. So how to sense that? Got it? So in that way actually we can able to discuss the various sign of thermodynamic statements. Right? See, first we'll go with the non-spontaneous process. That is what, see, for the classic statement, simply you just consider always with respect to the refrigeration or air conditioner. Right? So in the air conditioner, how it is working actually, the inside room temperature is nothing but during summer season we are having around 30 degrees Celsius, and around the atmosphere also I'm having 35 or 40 degrees Celsius during summer season, right? But I need to maintain the room temperature as 20 degrees Celsius or 22 degrees Celsius. So for that I need to evacuate these heat energy, right, from inside room to the surrounding. Right? So like that I say actually I supposed to consider. See, but with respect to the statement, how to write the statement is nothing but, see, we are giving the impossible conditions over here. So then which is possible, that we can easily able to understand. See here, it is impossible to construct a device, right, which operates on a cycle. So it follows more number of cyclic process we are having and produces no other effect. It can't be able to produce no other effect, right, than the transfer of heat from a cooler body to hotter body. Right? So what they said actually, see, it is impossible to construct, they said, with no other effect, which means with other effect it is possible, right? So that is what the Clausius statement they have given. See, it is applicable to a particular device, impossible to construct a device, right? Or fabricate a particular device which operates on a cycle, that is operating on a cyclic process we are having, right? In that actually we may have heating process, compression process, condensation process, whatever it may be, expansion process, whatever it may be, right? And produces no other effect, right? Without other effect actually, no other effect than the transfer of heat from a cooler body to hotter body. So it is impossible to construct to transfer of heat from cooler body to hotter body with no other effect. So with other effect then, right, it is possible, right? So by expenditure of some work done, right, so I can able to transfer the heat from a cooler body to hotter body. That is what the conservation says, right? Conservation of energy is nothing but it is we can't able to destroy or we can't able to form it. It is converted from one form to another form. So by expenditure of other effect, what is that work done, right? Then I can able to convert that into the transfer of heat from cooler body to hotter body. So for that I required some particular specified conditions also with the working substance, right? So the heat transfer will take place with respect to the working substance. Here actually I said only with respect to the system, between the system and surrounding, or between the two systems, right? So like that actually we supposed to consider. So in the vice versa manner, you have to understand the Clausius statement. Then you can able to understand the feasibility of a particular statement. See this Clausius statement, as I said, what I said actually in the previous slide. So this is what TL, this is what your TH, higher temperature, right? So with other effect, it is very possible to construct a device. Okay. So this is what this statement given, right? See, that is what with no other effect. If I consider the work done inside supply, work done equal to 0, right? What is this? TL is nothing but we are having, assume that this is the refrigeration space we are having. This is your high temperature, right? Without supplying any work input to the system, through that the conversion will be there, right? From electrical energy to mechanical energy that we are having in the conversion, right? So until if you supply, if you are not supplying any work input to the system, we can't able to transfer this. That is what the statement given. Always the temperature TH, that is a specified condition they have given. TH is always nothing but greater than the TL. That is the specified condition they have given. So TH is higher, TL is lower. So for this it is impossible to construct it. So when the work done is some value, actually I am giving work done input to the system, then it is possible. You got it? So this is the statement actually given by the Clausius. So this is applicable to the refrigeration system, right? And heat pump, right? Your room heater, how it is working, right? So that is what actually we are having the applications with respect to the heat pump. So this is what a simple Clausius statement actually we are having with respect to the which one actually the direction from cold body to hot body. That is actually non-spontaneous process, right? So there also it is applicable, right? So in the vice versa, actually we can able to say these are the corollaries of Clausius statement we can able to say. See what they said actually, the heat can't flow itself. See itself, right? By itself it can't able to flow. Then by inducing from the other thing, we can able to transfer the heat from cold body to hot body. By itself actually, itself in the sense spontaneously. So spontaneously it can't able to transfer from colder body to hot body, right? So itself it can't able to transfer by, but if I'm inducing from outside, we can able to transfer it, right? Okay. So in that way we can able to understand. See, the sign law is also used to determine the theoretical limits of the performance of mostly used engineering systems like heat engines and heat pump. So this statement from colder body to hotter body is nothing but actually with respect to the heat pump I can able to say with the class A statement. For this heat engine actually I can able to have the Kelvin statement, Kelvin Planck statement, right? So this is what actually we are having with respect to the class A statement in the different way, right? Next one. Now what about the Kelvin Planck statement? Now for the non-spontaneous process, non-spontaneous device actually we are having, for that we have applied. But with respect to the spontaneous one, right? From hot body to cold body, always we, in your intermediate level, you have studied that if I place a cup of, if I place a tea, right, with respect to the hot conditions, what happens with the surrounding temperature itself, right? Automatically it gets cooled down. So that is why the equilibrium conditions we are having, right? So there actually the zeroth law of thermodynamics it applies. Right? So the in a cup actually we are having the hot tea over there. If I place it on the table with respect to the room temperature, right? So obviously after particular time taken, right, it reaches the room temperature also. That is what the equilibrium conditions we are having. So this is what actually we call it as the spontaneous one, right? See the statement again, we are having the impossible conditions over there. Then how to relate with respect to the possible conditions, right? So it is impossible to construct a device, right, which operates on a cycle again and produces no other effect than the transfer of heat from single body in order to produce work, right? So what it states actually, so the transfer of heat, right, from a single body, only with respect to the single body the transfer of heat won't take place, right, in order to produce that into work done, right, with no other effect, it is impossible to construct. Got it? So with other effect, what is that other effect actually? So with the single body system actually it won't works. Why? Because it is always surrounded by the surroundings, right, atmosphere we are having. That is what we can able to say, that is nothing but sink, right? If I consider only the system and surrounding, but in the two system, in the sense they are actually supposed to have supposed to consider which is having high temperature and which is having low temperature, right? So with that actually I can't able to produce the work. But with other effect, right? So if I'm having the two body system over there, that is a system and another one is nothing but surrounding. So that is what source, and we are having sink. Source is nothing but actually we are having the high temperature body, and sink is nothing but always, see, always we are surrounding with respect to the atmosphere. So that is always nothing but sink. So if it is wherever we are having the sink or lower body temperature, right? So if I consider between two system, there actually I supposed to consider lower body temperature, right? So there actually some heat is rejected to the system or to the surrounding, right? So the heat transfer takes place to the surrounding. That is what with that effect, right, I can able to produce the work done until I can't able to produce the work done. Got it? So it is possible to construct that device, right, which produces other effect. What is that actually? Heat rejection to the surrounding, heat rejection to the sink. Then I can able to transfer a heat from a single body to the surrounding, right? There actually I supposed to use, right, two systems, two body systems in order to produce the work done. So there it is possible, right? So if you want to visualize with respect to that, see, only this body actually we are having, this is the heat supplied QS. So according to this statement, what happened actually? W equal to Q. What is that actually? Summation of W equal to summation of Q. Again, we are having the series limitations with respect to the first law of thermodynamics. Then what happened actually? If I rejected this heat to particular next body, or we can say surrounding, as in this is the surrounding we are having, what happened? Then QR. This is QS heat rejection, QR. Then I can able to get the mechanical work done. You got the concept? Then that is possible. So this is actually impossible with a single body system, right? So obviously I supposed to consider the source and I supposed to consider the sink over there. Those are all actually, we call it as reservoir. These are the consideration for the sign of thermodynamics that I forgot to tell, right? So these are all the reservoirs, source and sink. Source is always nothing but having a plenty of available energy, right? Okay, infinitely we are having available energies over there. That is the heat supplied over there. Okay, no? Here the sink is nothing but actually infinitely it absorbs the heat energy from the source, right? So this is what actually we are having the two reservoirs. These conditions actually, these are the specific conditions. These actually conditions we didn't discuss in the first of thermodynamics. So with these conditions actually I can able to overcome the first of thermodynamics, and then I can able to enter into second of thermodynamics, so that I can able to evaluate the performance parameters, right? So this is the possible case if you consider all these things. So this is what the Kelvin Planck statement. So this is applicable with respect to the heat engine from hot body to cold body, right? So here the hot body is nothing but source, and that is nothing but heat engine that operates actually in between. What is that source actually we are having? From the calorific value of the fuel, I'm getting all the heat energies, right? Then what is that sink actually for this heat engine? Surroundings we can able to consider, right? So this is what the statement given by the Kelvin Planck statement. So which is applicable to the spontaneous process, or we can say for the heat engines we can able to apply, right? Next one. So next actually it leads to the entropy statement. This actually we'll discuss in detail after discussing about the heat engine, refrigerator and heat pump. But as of now we'll discuss about the entropy statement, right? See, the sign of thermodynamics states that the state of entropy of the entire universe, right, as an isolated system will always increase over time, right? So that is what always increase over time in the sense. See, with respect to the equilibrium conditions, everyone knows that from hot body to cold body, now to attain the equilibrium conditions, right? So the entire universe is nothing but actually trying to attain the equilibrium conditions. So which means the transfer of heat from always takes place between the two systems. So that the momentum get creates, so that the randomness of the particular system creates. So will always increase over time, right? So the sign law also states that the change in the entropy in the universe can never be negative. This is what the statement I have given. Right? So if I frame the class as inequality, that is what actually in the upcoming lecture actually we are going to discuss about that. So the class as inequality actually we are going to derive it. If I know that the class is inequality, then we can able to sense the changes in the entropy of the universe. Universe is nothing but actually system plus surrounding, right? Can never be negative. So which means it is always positive. That actually we can able to justify it. So this is what another kind of statement actually we are having. So further we supposed to know what is moving entropy, and by mathematically how we need to represent it, and why it can't be always negative. So we need to frame all mathematical relations. So from the classes inequality, I can able to lead that actually. So in the upcoming lecture, we'll discuss about the entropy and the entropy statement and increase. What is that actually? Can't be negative in the sense increase in entropy principle. So that we will discuss in the next lectures, right? In the upcoming lectures. So this is what actually we are having alternative statement or prominent statement of sign of thermodynamics actually we are having, right? So in the next lecture, we'll discuss about in detail about the class A statement and Kelvin Planck statement with respect to the practical applications like heat engine and heat pump I said, right? So like that we'll discuss. So thank you everyone.